88, we need to graph this exponential function and this logarithmic function. So in order to do that accurately, make a table for each of them going from -3 to +3 and plot the points. You should see that one of them goes like that, the other one goes, oops, the other one goes like that. And then state the domain and the range and the zeros of each function. Okay, so for the domain and the range, the x and the y should switch. The domain and the range should switch. And when it comes to the zeros, there's no x-intercept on this one, and the y-intercept is at 1. On this one, there's no y-intercept, and the x-intercept is at 1. So those are the zeros, okay? On 89, let f of x equal 3 times x. So let's take a look at this. It may be helpful to first replace these. There's some examples. So the first one, f of x, or f of 4, so we do 3 times 4, and that's 12. Hold on. Just kidding. This is actually a misprint from if I just looked at your book, and this says 3 to the x power. That makes a whole lot more sense. So the function is actually an exponential 3 to the x, and so it's going to be 3 to the 4th power, which is 81. Now we want to do the inverse of 81. So what would be the inverse of that function? Well, it's just what undoes this. We got 81 as an output from this one, so the inverse of it, we would get back what we put in, so the output would be 4. Okay, on this one, if the input is -2, so we have 3 to the power of -2. 3 to the power of -2, it's the inverse, so we get 1/9. And then if we put this into the inverse function, it undoes it. So what should come out? A -2. On the next one, if we put in a 1/2, it's 3 to the power of 1/2, which is the same as square root of 3. So if we put the square root of 3 in, the opposite of that, or we should get 1/2 out. So notice how these are grouped together, these are grouped together, and these are grouped together. They're the do and undo of each of those. All right, on 90, we're to graph a log with base 5 of x plus 2. I'd like to look at it that way because it is really just shifted. We're used to seeing things looking like that instead. So this tells me that it shifted 2 spaces to the left. So if here's my axes, my asymptote moves over 2 spaces to the left, and there's the asymptote. And a log is going to go like that. And determine the domain and the range. So the domain is everything from -2 and up. It can't be exactly -2 because that's an asymptote. We don't actually reach that. And then the range is all real. Okay, next one. Okay, this is a really great review problem. Let's remember that f of x can be replaced with y. And the strategy for this, we really need to switch. We're going to use the switch x and y method and then solve. We haven't done one of these in a while, and it's really important to practice. So instead of y, x. Instead of x, y. And we need to replace both of the x's with y's. There we go. Now we need to get y by itself. So the first step, we'll multiply both sides of this problem by 2y. Here, let me switch colors to make the work clear. Okay, so we're going to multiply this side by 2y and this side by 2y. And that cancels. So we end up with 2xy, multiply all that together, equals y plus 3. So the next step, we want to get the y's all on the same side. So let's subtract a y from both sides. And we end up with 2xy minus y equals 3. So then we can factor out a y, and we get y times 2x minus 1. That equals 3. And the last step, divide both sides by 2x minus 1. And so our final is y is equal to, because those cross out, y is equal to 3 over 2x minus 1. All right, 107. Evaluate the following logs without a calculator. Look, no calculator allowed. Okay, so log base 3 of 81. So to evaluate this, thought bubble, we're thinking 3 to the what equals 81. So 3 to what power is 81? That would be 4. So this equals 4. All right, thought bubble on this one. I'm thinking 5 to what power equals square root of 5? Well, square root of 5, the square root is the same as the power of 1/2. So it's really to the power of 1/2. And on this one, thought bubble, I'm thinking 4 to what power equals 1/16? Well, I need this to do a reciprocal, so it's going to be a negative, and I need it to be 16, so squared, so I'm thinking -2. Okay, 108, use the law of logs. We learned 3 laws to write each as a single log. So we're compressing, we're basically using it to put all these together. Well, let's look at this piece first. Log of 4 plus log of 2, what we learned is it's 4 times 2, so this is the same as the log of 8. And then we've got log of 8 minus log of 5. Subtracting is the same as division, so we end up with log of 8/5. And then on this one we can simplify log base 2 of m plus 2 times log base 2 of n. Well, the first thing you always want to do is deal with these. If you ever have a number in front, that gets shifted over to become an exponent. So what we have is log base 2 of m plus log base 2 of n squared. Now we're ready to put these two together. It's kind of like order of operations. You always need to deal with things that have exponents first, and then we'll do the adding and multiplying. So adding indicates multiplication according to our rules, so we end up with log base 2 of m times n squared. All right, 109. Show that log base 4 of x is equal to is equal to half log base 2 of x. Okay, so we've got one is in base 4 and one is in base 2. So let's start with, as it suggests, this one and change this to exponent form. So if I say that y is equal to log base 4 of x, let's change it around. We end up with 4 to the y power equals x. So now let's work on this one. So y is equal to, I'm going to go ahead and move this 1/2 up as an exponent. So I end up with log base 2 of x to the 1/2 power. And let's rewrite this as an exponential. So the base is 2. So it's 2 to the y power equals x to the 1/2 power. Okay, now my goal is to make these show that these are equivalent. So if I make this the same base, I get 2 squared to the y power equals x. And on this one, since this is raised to the 1/2 power, I could raise both of these to the power of 2. And that would be 2 to the 2y equals 1/2 times 2 makes 1. So x to the power of 1 is just plain old x. And now they're exactly identical. That was a kind of tricky one. Okay, review over angles. I see this going in the positive direction, so I'm just going to have a positive. It goes all the way around, so I've got a 2 pi. And then in addition to the 2 pi, I've got all the way to right here. Well, this looks to me like it's one of the thirds. It's not exactly in the middle. So I'm going to do 6. This is 1/6, 2/6, 3/6, 4/6, and 4/6 reduces to 2/3. So I'm going to call that 2/3 pi. And I need to add these together, so I need to make a common denominator here, thirds. So if this is thirds, then it's 6/3. So 6/3 plus, or 6 plus 2, I've got 8 pi over 3. Another way to do that is just to keep counting all the way around. 1, 6, 2, 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I end up with 16/6. Is 16/6 the same as 8/3? Yep, it sure is. Okay, now this one we're going backwards, so it's going to be a negative. And this to me looks like it's not exactly in the middle, so it's going to be one of the thirds, or one of the sixths. So I'm going to count backwards to 6. 1/6, 2/6, 3/6, 4/6, 5/6. So negative 5/6 pi. Don't forget how to count those. Okay, so we need to find the inverse of each of these. Now this one, there's 2 different methods now that we have to choose from. This one only has one x in it, so I'm just going to do my undo version in my head here. So I've got the inverse of f of x should be, you take the x, and the last thing done here is cube root, so that's the first thing I'm going to inverse. I'm going to do the power of 3. Then it was a -5, so the opposite of that would be +5, and then a times 3, so the opposite of that would be divide by 3, and there's the inverse. So that's one that can be sort of done in your head. If you're not very good with that strategy, don't use it. Switch x and y, or make your list of undos. Okay, this one, I've got an x in the numerator and the denominator, so we absolutely need to switch x and y. So this is like my y. I'm going to put x here and do 2y minus 1 over 3 minus y. And remember, the first step is to multiply both sides by the denominator, so I'm going to end up with this canceling out, and this gets multiplied over here. So we'll go ahead and distribute, and I get 3x minus xy equals 2y minus 1. Then I need all the pieces with y's in them on one side and all of the pieces without on the other. So I'm going to add the 1 to this side and add this to this side. So I get 3x plus 1, and add this over here, 2y plus xy. Now let's factor out y. So we have y times 2 plus x equals 3x plus 1. and divide both sides by 2 plus x. And so here's our inverse. The inverse function of g is 3x plus 1 over 2 plus x. Now, it looks like some numbers switched around and some signs switched around. It's too dangerous to kind of look for a pattern and see. You need to know how to do this process. Okay, and C. We need to find the inverse of a logarithm. The easiest way to do this is to put it in exponential form. So this is my y, and if I rewrite this as an exponential form, I've got 3 as a base to the power of y is equal to x minus 1. So then the inverse of this is what we get when we switch x and y. So this, I did not switch x and y yet. I just did a rewrite into exponential form. Now that it's in exponential form, I'm going to do the inverse by switching x and y. So now I've got 3 to the x equals y minus 1. To get y by itself, all I need to do is add 1 to both sides, so y is equal to 3 to the x plus 1. And this is the inverse. So h to the negative 1 of x is 3 to the x power plus 1. All right, last one, 114. Rewrite each in this form. Okay, this is where we do the splitting this into pieces. So this becomes 16 times 1/2 to the power of 2x times 1/2 to the power of 1. Do you remember if these are added, we could split those? And then let's simplify this. Okay, 1/2 to the 1 is just plain 1/2. So 1/2 times 16, 1/2 of 16 is 8. And then for the base right here, I've got this all raised to the power of 2. I can simplify that, and it ends up being 1 at a times right here. 1 over 4 to the power of x. All right, let's repeat that with this one. Okay, I'm going to assume that this is the exponent on the 25 here, so I'm going to break this up into 100 times 25 to the half x power times 25 to the negative 1 power. Let's simplify those. So I've got 100 times, well, 25 to the 1/2. That's the same as square rooting 25. So square root of 25 is just 5. So it means 5 to the x power. And 25 to the negative 1, reciprocal, makes that 25. 100 times 1/25, that cuts that in 4 pieces, so it's 4 times 5 to the x is the simplified version of that. And that's the end.